Hi, my name is M. Manusha, Assistant Professor in Mechanical Department. Today I am going to derive an expression for Jacobian matrix for two noded and four-dimensional quadrilateral element. Okay. So Jacobian matrix for two noded isoparametric quadrilateral element. So we are taking the example of quadrilateral element. Actually previous class also we done an example expression for a quadrilateral element. Today also we have to find out the Jacobian matrix. We have to take the example of quadrilateral element. First we have to take the quadrilateral element. This is the x axis and this is the y axis. So this is the quadrilateral element. So node 1, node 2, node 3 and node 4. So every node is having the two directions, that is x and y. X having the u1 displacement and y means v1 displacement for node 1. For node 2 similarly u2 and v2. For node 3 u3 and v3. For node 4 u4 and v4. Okay, this is a quadrilateral element. It having the four nodes. Each node is having the two directions, that is x and y is having the u1 and v1 displacement. So u1, u2, u3 and u4 are displacements along x axis. Similarly, v1, v2, v3 and v4 are displacements along y axis. For quadrilateral element, in previous class already we derived the shape functions. So n1, n2, n3 and n4 are the shape functions. So for deriving the Jacobian matrix, we are taken as x and y parameters. For x and y, we are taken as xi and eta parameters. So let f is equal to f of xy. For x comma y, we are taken as xi comma eta are the parameters. So for this f of x comma y equal to xi comma eta, we have to partial derivative to each other. So dou f by dou x, sorry, with respect to xi, dou f by dou xi is equal to, with respect to dou f by dou x into dou x by dou xi. With respect to xi, we are partial differentiation plus dou f by dou y into dou y by dou xi. Similarly, for eta, dou f by dou eta is equal to dou f by dou x into dou x by dou eta plus for y dou f by dou y into dou y by dou eta. This is the equation number 1 and this is the equation number 2. After this, we have to write these two equations in matrix form. Write 1 and 2 equations in matrix form. First dou f by dou xi and dou f by dou eta. Dou f by dou xi, dou f by dou eta is equal to, so we have to write in the matrix form, dou f by dou x and dou f by dou y. Okay. First dou f by dou x term, what is the dou x by dou xi? Dou f by dou x into dou x by dou xi. Here dou x by dou xi is there, here dou f by dou x. Next, similarly for dou f by dou y, here related term dou y by dou xi. So by writing this matrix form, we come same equation. Similarly, here also for dou f by dou x by eta into dou y by dou eta. So this is the two equations we have to write in the matrix form. So after that, we are taking this matrix as J, that is Jacobian. So total matrix are taken as J. So dou F by dou xi into dou F by dou eta is equal to J into dou F by dou x into dou F by dou y. Okay, we have to find out the x and y parameters. So in order to find out the x and y parameters, we have to write right side dou F by dou y is equal to, it will come as J inverse into this term dou F by dou xi into dou F by dou eta. So J inverse, how to find J inverse? Inverse of J, inverse matrix formula is, so for example det A into, so A inverse means 1 by A into B minus B minus C A. This is the formula for finding out the inverse. For J inverse, 1 by J into D minus B minus C A. So where J is equal to J matrix dou x by dou xi, dou y by dou xi into dou x by dou eta into dou y by dou eta. This is the J matrix. This J matrix will be written as, this is the first row and this is the first column. So J first row and first column, J11. Again this term can be written as first row second column. So first row and second column, J12. And this dou x by dou eta can be written as second row first column. So J second row first column, J21. Again this can be written as second row second column, J22. Okay. So this is a Jacobian matrix, write in row and column matrix. So this J matrix we have to write in this equation. So like this we have to write these equations. So finally we come this matrix equation. In this matrix equation we have to replace F is equal to U. So dou U by dou x, dou U by dou y is equal to 1 by det J into J22 minus J12 minus J21 J11 into dou V by dou xi, dou V by dou eta. This is a second matrix. Write these two equations in strain displacement equation form. So strain displacement equation form means it having the E. E is denoted by strain. Strain is denoted by E, having x, y and z axis. In x axis we are taking as dou U by dou x. So dou U by dou x. Y axis dou V by dou y. So this is a dou V by dou y. So z axis means combination both. So dou U by dou y and remaining plus dou V by dou x. So this is a matrix. So this is a total matrix come in between this. So here dou U by dou xi, dou U by dou eta, in second matrix dou V by dou xi and dou V by dou eta. So in middle of the matrix first we have to take dou U by dou xi term. So this is the dou U by dou xi. So here J22 into dou U by dou xi. So dou U by dou xi already written here. So he have to write here J22 only minus plus dou U by dou eta. This is a dou U by dou eta term. So minus J12 into dou U by dou eta. So dou U by dou eta already written outside. So remaining minus J12 matrix. Next similarly dou V by dou xi and dou V by dou eta terms are not there in first equation. So we have to take 0 0. Again in second matrix also dou V by dou V terms have to take in this matrix and remaining x terms have to take 0. Here both x and y axis are there. So, here dou u by dou xi term. So, this is a dou u by dou xi and dou u by dou eta minus j21 j11, and similarly dou v by dou xi and dou v by dou eta, dou v by dou xi and this is a dou v by dou eta. So, j22 and minus j12. So, like this we have to write in the total matrix form. So, after that already we know the for displacement x axis n1 u1 plus n2 u2 plus n3 u3 plus n4 u4. Similarly, for y axis also n1 v1 plus n2 v2 plus n3 v3 plus n4 v4. This is the shape function equations for displacement along x axis and y axis. For this we have to write for related to xi and eta parameters. With respect to xi, dou x by dou xi is equal to, so we have to partial derivative to all the terms. So, dou n1 by dou xi into u1 plus for n2 u2 dou n2 by dou xi into u2 plus dou n3 by dou xi into u3 plus dou n4 by dou xi into u4. Similarly, dou y by dou xi is equal to, dou y by dou eta term. So, already we have to take xi term. For same x term we have to take the dou n1 by dou xi into u1 plus dou n2 by dou xi into u2. Okay. Next for this is the xi parameter. Next for similarly for eta parameter dou x by dou eta is equal to dou ny dou eta into u1 plus dou n2 by dou eta into u2 plus dou n3 by dou eta into u3 plus dou n4 by dou eta into u4. Similarly, for y displacemental axis, dou y by dou xi is equal to dou v1 by dou xi into u1 plus dou v1 by dou xi into u2 plus dou v3 by dou xi in. Okay. So, similarly for y axis dou y by dou xi is equal to n1 v1. So, dou n1 by dou xi into v1 plus dou n2 by dou xi into v2 plus dou n3 by dou xi into v3 plus dou n4 by dou xi into v4. Similarly, for eta parameter is equal to dou n1 by dou eta into v1 plus dou n2 by dou eta into v2 plus dou n3 by dou eta into v3 plus dou n4 by dou eta into v4. These are the 4 equations related to x and y displacemental axis. After that, already we derived the shape function equations n1, n2, n3 and n4 for quadrilateral element. In previous derivation already we derived the n1, n2, n3, n4 equations. We have to substitute the n1, n2, n3, n4 equations in these equations 3, 4 and this is the 5 and this is the 6. So, first we have to write these 4 equations again in matrix form. So, those 4 equations we have to write in this matrix form. These are the displacements along the x and y axis u1, v1, u2, v2, u3, v3 and u4, v4 along the 4 nodes. Okay. So, already we know that shape function equations in quadrilateral element. So, n1 is equal to 1 by 4 into 1 minus xi into 1 minus eta equal to dou by dou xi of n1. n1 means 1 by 4 into 1 minus xi into 1 minus eta. Okay, this is the n1. We have to partial derivative of this n1 with respect to xi. So, we are doing with respect to xi 1 by 4 into 1 minus eta into dou by dou xi of 1 minus xi into 1 by 4 into 1 minus eta into with respect to xi dou by dou x of x means 1, dou by dou x of minus x means minus 1. Here minus xi is there. So, dou by dou xi of minus xi means minus 1 here. So, therefore, minus 1 by 4 into 1 minus eta, this value. Next, similarly for dou n2 by dou xi, dou n2 by dou xi is equal to, so that is equal to dou by dou x of minus x, here also minus x. So, minus 1 by 4 into 1 plus eta. Similarly, dou n3 by dou xi is equal to dou by dou xi of n3 1 by 1 plus eta, that is equal to 1 by 4 into 1 plus xi into dou by dou xi of 1 plus, sorry, here 1 plus eta into 1 plus xi. So, here dou by dou x of positive xi. So, dou by dou x of x means x, positive x. So, 1 by 4 into 1 plus eta. So, constant term means dou by dou xi of constant term means 0. So, similarly, dou n4 by dou xi is equal to dou by dou xi of 1 by 4 into shape function n4, 1 plus xi into 1 minus xi, that is equal to, with respect to xi we have to take. So, dou by dou xi into 1 minus eta, sorry, here 1 minus eta into 1 by 4 into dou by dou xi of 1 plus xi, that is equal to 1 by 4 into 1 minus eta for dou n4 by dou xi. Similarly, we have to calculate for eta parameter also. Dou n1 by dou eta, that is equal to dou by dou eta of n1 1 by 4 into 1 minus xi. So, 1 by 4 into, with respect to eta we have to calculate dou by dou eta into 1 minus eta. So, 1 by 4 into 1 minus xi into dou by dou eta of minus eta means dou by dou x of x means 1, dou by dou x of minus x means minus 1. So, here minus eta will be came. So, that means minus 1. So, minus 1 by 4 into 1 minus xi. Similarly, dou n2 by dou eta is equal to dou by dou eta into 1 by 4 into n2 term 1 minus xi into 1 plus eta, that is equal to 1 by 4 into 1 minus xi. Similarly, dou n3 by eta is equal to dou by dou eta of 1 by 4 into 1 plus xi into 1 plus eta. So, that is equal to 1 by 4 into 1 plus xi. Similarly, dou n4 by dou eta is equal to dou by dou eta of 1 by 4 into n4 1 plus xi into 1 minus eta. So that is equal to 1 by 4 into 1 plus xi. Here minus eta will be there. So here we get minus. So these are the terms we come for this matrix equation. So these values have to substitute in this equation number 6. Okay. So at last we have to submit those n1, n2, n3, n4 related to xi and eta parameters. We have to write in these equations in this matrix form. After writing in this matrix form, already we have to done the strain displacement matrix equation here. So this dou u by dou xi, dou u by dou eta, dou v by dou xi and dou v by dou eta matrix we have to find finally. So those matrix form we have to submit in this strain displacement matrix equation. So finally we get E is equal to this total displacement matrix into this final matrix. So this final matrix became, okay. So here, so this is the total strain displacement matrix. Strain means it is denoted by E. So E is equal to this total we have to taken as B. The total will be taken as B displacemental matrix. So E is equal to B into U1, U2, V3, V4 up to U1, U2, U2, U3, U4 and V1, V2, V3, V4 are the displacements along X and Y axis. So for displacemental axis we have to taken as Q. Okay. So this is the strain displacement matrix and this is the total B matrix and this is the displacement matrix. Okay, displacement matrix is written as Q and strain displacement matrix is written as E and total, this middle displacement total will be written as B. So this is the finally we get the Jacobian matrix into this equation matrix. Okay, thank you.